Hello 8th grade, we're going to be doing simplifying radicals today. So we're going to use what we talked about the day before regarding perfect squares. So let's take a look at our warm-up, pause the video, write down your answer in your notebook. When you're ready, press play and we'll work on this together. Okay, so there's a couple things that we can notice. Let's call this group row 1, this group row 2. So similarly, all of them are not perfect squares. None of these numbers in the radicals are considered perfect squares. You may have also noticed that the numbers in row 1, 3, 5, 7, and 11 are prime numbers. Prime numbers are numbers that only have factors of 1 and itself. So 3 can only have the factors of 1 and 3. 5 only has the factors of 1 and 5. 7 only has the factors of 1 and 7. 11 has the factors of only 1 and 11. The other ones, however, all have multiple factors and they are not prime. For example, 6 has the factors of 1, 2, 3, and 6. 18 has the factors of 1, 2, 3, 6, 9, and 18. 30 has the factors of 1, 2, 3, 4, 5, 10, 15, and 30. And 27 also has the factors of 1, 3, 9, and 27. So row 1 are prime. Row 2 have multiple factors. Now, these in row 1, radical 3, radical 5, radical 7, radical 11, all cannot be written any other way. That's it. They don't have any special factors. That is all. Okay? So there's no other way we can write those ones in row 1. Now let's take a look at row 2. They have multiple factors, and that means something. Now take a look at those factors. There's something special about some of them. In radical 18, right, the factors of 18, 9 is a perfect square. When we look at 30, 4 is a perfect square. When we look at 27, 9 is a perfect square. 6 is the only one that does not have a perfect square as a factor. Since radical 6 does not have a perfect square as a factor, radical 6 can only be written as radical 6. It almost belongs in row 1. Now, we're going to take a closer look at the numbers that closer look at radicals that are like radical 18, radical 30, radical 27. Because these numbers have factors that are perfect squares, we can simplify it. So let's take a closer look at the radical 18. We can rewrite this using factors. So take a close look at those factors. We're going to use the perfect square, 9. So how can we rewrite 18 using the number 9? Good, 9 times 2. We can break that up. Now we can have radical 9 times radical 2. And then we can simplify if we can. Radical 9, same thing as square root of 9, is just 3. And radical 2 is just going to say radical 2. And that's it. I know in previous days we said radical 9 can have two answers, positive and negative. We're only going to focus on positive. When we simplify, we're only going to leave it as positives. That negative stuff will come more into play when we're solving more intense problems later in the year and in high school. But this is it. 3 radical 2. 3 times the square root of radical 2. That's what that means. And it's an irrational number, and we can keep it that way. Let's do a couple more examples. Let's take a look at radical 45. 45 is not a prime number, so let's take a look at some of the factors of 45. 1 is a factor. It goes in evenly. 3 is a factor. 5 is a factor, right? So the way you think about it is 1 goes into 45 times. Sometimes it's even helpful to just write the pairs, so I'm going to actually do that. 1 times 45, not 2, but 3 times 15 works. 5 times 9, and I believe that's it. So these are our factor pairs. Do any of those factors pairs have a perfect square in it? Yes, they do. 9. 9's our perfect square. 9 is a perfect square because 3 times 3 is 9. And we're going to use that to help us simplify square root of 45. So our first step is rewrite rewrite 45 using a perfect square. So 9 times 5. So I'm just going to kind of note off to the side what we're doing here. We're going to rewrite I'm going to do it generally. Rewrite the number in the radical using a perfect square factor. Okay, next we're going to break up that radical 9 times radical 5. Next, we're going to simplify. We're going to ask ourselves, can we simplify radical 9? Yes, we can. Radical 9 is 3. Radical 5, can that be rewritten any other way? Nope, it's just going to be radical 5. And that is our answer. That's the irrational number. So we rewrote the number in the radical using the perfect square factor, which was 9 in this case. Then we simplified further. And that's it. Let's try another one together. 112. 112. So same thing. We know 112 is not a prime number and it has multiple factors. So let's figure out if we can simplify it further. So if we have 112, we have to think, well, what numbers times each other equal 112? So 1 and 112. 2 goes into 112 56 times. Right. What about 3? Nope, 3 does not work. 4 and 28. 5 can't go into 112. Maybe 6 can. Nope. 7 won't. 8 does. 8 goes in 14 times. And actually 16 goes in there 7 times. Okay, missed one. Okay, so looking at these, which factors have a perfect square? 16. 16 and 7. So we can rewrite 112 as 16 times 7. Break up 16 and the 7. We take a look and we say, can radical 16 be simplified further? And yes, because it is a perfect square. Square root of 16 is 4. And we leave square root of 7 because it cannot be no longer simplified. So we're left with 4 radical 7, and that is it. And that's pretty much it. I just want to take a closer look at when we were finding the factors. Now you can use your calculator and you can go through the numbers, kind of like what we did. Or you can kind of just use your perfect squares. If you remember your perfect squares, so 1, 4, 9, 16, 25, 36, and so on, right? If we know those, we can just divide the number that's inside the radical by the perfect squares and see if there's a factor, right? So we could have done that from the beginning and realized that 4 was a factor and 16 was a factor. Now, if you noticed, in that list of 112, 4 is also a perfect square, and we could have used that, but 28 can be broken down even further. So you got to make sure you're choosing the factor pair with the largest perfect square, okay? So again, this is pretty much it. Pretty straightforward. You're going to take that radical. You're going to find if it has a perfect square as a factor. You're going to use it, and you're going to use that to simplify, okay? I want you to pause your video, and I want you to do this quick check on your own when you're ready. Unpause it, and we will go through it together. Okay, let's take a look at 12. So thinking about 12 as a number, it has multiple factors. I'm going to put the perfect squares up at the top here. 1, 2, oops, not 1, 2. 1, 4, 9, 16, 25, 36, 64, I always forget 49, 49, 64, and so on. And if we need more, we'll keep going. So 12, looking at those perfect squares, right? Do any of those numbers go into 12 evenly? 4 does. 4 times what? Which is 3. So 1 goes into 12 also, so 1 times 12, so that's good. 4 goes into 4 times 3. 9 doesn't go into 12, 16, and then we're done. Okay. Well, we know that 4 is a perfect square, so we can rewrite 12 as 4 times 3. Could break that up. Then we have 2 times radical 3. Let's take a look at 80. Again, looking at those perfect squares as help, right? So we're going to start with 1. 1 times 80, that's true. 4 is next. 4 times 20. 9 does not go into 80. So we just did 9. 9 doesn't work. Then we have 16. 16 works because 16 times 5. Then we're at 25. 25 doesn't go into 80 evenly. 36 is next. That doesn't go into 80 evenly. And we're already at 49, and that doesn't work. Okay, so these are our numbers. These are our perfect squares. So we're going to take the one that's the largest, and we're going to rewrite 80 using the largest perfect square factor, which is 16 times 5. I'm going to break it up. We have 4 radical 5. That's it. Let's try one more. Radical 23. So we're looking at radical 23. The factors of 23 using perfect squares. So let's the first one is 1. 1 goes into 23 evenly, so 1 and 23. 4. So we used 1. 4 doesn't go in evenly. 9 doesn't. 16 doesn't. We're already at 25. So this is it. Radical 23 can only be written as radical 23. There's no simplifying to be done. All right, well, that's pretty much it for today's lesson. You're going to do the independent practice on your own. This is due by tomorrow. And that's pretty much it. So what you're going to do is you're going to upload it onto Google Classroom. So when you're done with it, please take a picture of your independent practice, scan it, and attach it to the assignment, and then make sure you turn it in. Okay? If you have any questions, please let me know. See you tomorrow.